Hello everyone, and thanks for watching Edupedia World videos. In this session of atomic structure, we'll be starting with the discovery of charge on electron, right? And then we'll go into the details of the experiment involved and further importance about the charge of an electron. So let's start with the discovery. The charge on an electron was first measured using an experiment called oil drop experiment. Alright, it was conducted by R.A. Millikan and Harvey Fletcher as well. But R.A. Millikan actually received a Nobel Prize for his efforts in this experiment and as well as other concepts of physics. Alright, so this experiment that they carried out in early 20th century can be represented in a crude form by this diagram you can see now. Alright, so if you notice in this figure, we have two metal plates here. Okay, so this is the positive metal plate, that is our anode, and this is the negative metal plate, that is our cathode. Okay, so between these electrically charged brass plates we will have an electric field. Okay, we can vary the voltage applied in order to vary the electric field between the plates. Okay, so since there is an electric field present over here, any charged particle between these plates will experience an electric force. Alright, and by varying the voltage we can vary the electric force. Okay, so this is the major part of the experiment, and apart from this we have an atomizer here. Okay, in the upper section of the experiment, if you see, we have an atomizer. This atomizer is basically nothing but an apparatus which can spray very fine particles, very fine droplets of oil. Right, that is, the droplets are of atomic sizes, you can say. They are so fine, so small. That is why we use a special apparatus called atomizer here. Alright, so this tool helps us to produce very small droplets. Now the oil used here is of a specific kind. It is the type of oil which has very low vapor pressure. You might not understand what vapor pressure is at this stage. Okay, you will study that in detail in your class 12th, but for now, if you want, you can remember that oil used is of very low vapor pressure. This is to ensure that during the process of experiment, alright, during the discovery of charge itself, the oil that we are going to use, the droplets of oil, do not get evaporized. Alright, so if vapor pressure is low, vaporization will be low. Okay, so we can still observe our oil droplet throughout the experiment from top to bottom. Okay, so now we have a pinhole here on the upper brass plate, so that these droplets can one by one, alright, pass through this pinhole towards the bottom. Okay, so basically these are oil droplets of some mass. Obviously they will have certain amount of mass, which means they will have gravitational force acting upon them. So gravitational force is going to pull them down towards the bottom plate. Alright, so every droplet will like to go towards the bottom. Hence we have only made a pinhole here so that only a few droplets can enter at a time, and it will be easier for our observations and calculations. Okay, so one by one, let's see that these droplets starts their journey downwards. Okay, now as soon as they enter the electric field, that is between the brass plate, they are in presence of an electric field. Okay, so there will be an electric force exerting on them, but this electric force would only exert on charged particles. Okay, in the upper section, these are simply oil droplets. Oil droplets, like any other droplets of any other substance, by themselves are neutral, they are not charged. So we have to create charge here. So there can be two ways of creating charge on these oil droplets. First is the friction here at the nozzle. Alright, so the friction present over here can itself ionize some of the oil droplets. Okay, another way is to use X-rays. So if you see this wave here, this is an X-ray to produce charge on oil droplet. So just in this section of the experiment, at the top we can just pass X-rays over here. Okay, so one by one, as the droplets come by and they are struck with the X-ray, they get charged, alright, they get ionized. So now the oil droplet have become a charged oil droplet. The oil droplet has now become a charged oil droplet. So this charged oil droplet will now experience an electric force. It already experiences a gravitational force. Okay, and there will be another force that is called viscous force. Okay, we'll be studying that in physics, viscous drag force. So under the influence of these three different forces, the droplet starts to move down. Okay, and we can observe the whole experiment using this telescopic eyepiece present over here. Okay, we can observe these droplets over here and how they are moving in order to make certain changes during the process. Okay, so let's see what happens now. See, now we are going to ensure that electric force acts in the direction opposite to gravitational force. So there is gravitational force acting downwards, so we will ensure that electric force acts upward. Alright, so we'll maintain the polarity of these electric plates such that the electric force acting on the charged particle will be upwards. Alright, now this electric force is going to balance gravitational force. Alright, apart from the viscous force that is already present, these two forces would also need to be accounted for. Together these three forces can be balanced by changing the polarity, that is the magnitude of voltage applied. Okay, by varying that magnitude we can vary the forces. Okay, and by varying the force we can ensure that the net force applied on a charged droplet is zero. Once we know that net force is zero, we can ensure that the velocity charged droplet is constant. The velocity with which it falls is going to be constant, right? You must have studied this concept in physics, that when net force acting on an object is zero, it can move with a constant velocity. Okay, so that is going to be our goal here in this experiment, to ensure that the net force is zero. So we'll keep varying the voltage until we can observe from here that the velocity of the charged droplet has become constant. Alright, we don't have to go into the further details of this experiment. This crude representation, this rudimentary knowledge is more than sufficient for our syllabus and for our understanding at this moment. Alright, so let's move on to the more specific part of this experiment. Alright, how the charge was actually measured. So again, we have three different forces. Viscous force. Okay, now if you have not studied viscous force in physics, so let me just tell you that it acts opposite to the direction of velocity. So in this case we have, let's say, a charged droplet. So this droplet moves downwards, its velocity is downwards. So viscous force, okay, let's call it Fv. Viscous force is going to be acting upwards. Alright, so viscous force is going to be acting upwards on a charged droplet. It always acts opposite to the direction of velocity of an object. Okay, apart from that we have gravitational force. So gravitational force, let's call it Fg. Okay, let's call it Fg. Gravitational force obviously acts downwards. Alright, so gravitational force we know acts downwards on the particle Fg. Okay, so apart from that we have electric force. Apart from that we have electric force acting on this charged droplet. Let's call it Fe. Now again, electric force also acts upward. Okay, and net velocity of this charged droplet is going to be v downwards. So we have two forces acting in the upward direction, Fe, that is electric force, and Fv, that is viscous force. These two must equate the downward force of gravity, that is Fg. Okay, once this equation is satisfied, we can ensure that the droplet moves with constant velocity. And when it moves with constant velocity, we can assume that these forces have balanced each other out. Okay, so once we have observed that velocities are constant, we can use this equation. Now using this equation we can calculate charge on the droplet quite easily. Okay, so electric force is Q into V. Okay, we don't have to go into the detail of those calculations because that is something you are going to study in physics, and if you haven't studied that, you won't be able to understand them over here. Okay, this electric force is going to be part of your 12th standard physics. Okay, viscous force 6 pi eta RV. Again, we do not have to go into the detail of viscous force 6 pi eta RV. And gravitational force, you might be quite familiar with mg. Okay, mg. Here m is mass of the droplet. We can obviously calculate mass of the droplet. How we are going to do that? We know the type of oil that we are using, so we know the density of that oil, and density of anything is mass by volume. Okay, so mass of oil droplet, one droplet is going to be density multiplied with volume. What is the volume of oil droplet? If we know the radius of oil droplet, we can calculate approximate volume. Okay, assuming it to be spherical, we can simply write volume as 4 by 3 pi r cube. Though droplets are not exactly spherical, but we can calculate volume to an extent. So we can calculate the mass, we can substitute mass here, we can substitute electric force E into charge Q. Okay, we know the electric field E because we know the voltage applied, so we can simply calculate, erase this because this is V into Q actually, electric force. And second, you won't understand it right now, so let's move on. Okay, this is all we need to know, that once we balance these forces using this equation, we can very easily calculate the charge on an electron. So this is what Millikan did, and once he did that, he identified that charge on an electron is nothing but E equals to 1.6 into 10 to the power minus 19 coulomb approximately. Alright, his value was a bit different, it was 1.50 something, but it was within 1% error of this actual value, so it was quite acceptable and quite an achievement actually at that time. So once we have done this, we know that charge on an electron is always equal to this. Now see, the oil droplet need not necessarily have charge equal to one electron, charge on one electron. Okay. But what Millikan found was that charge on all the oil droplets, some oil droplets can have charge of say Q, then others he found had charge of 2Q, others had of 3Q. So what he found was that charge on every droplet was always an integral multiple of this charge, 1.6 multiplied with 10 to the power minus 19 coulomb. And this is how he deducted that. Okay, he made the deduction that this value must be the fundamental unit of charge, that is, this must be the value of charge on one single electron. So he actually brought about two different discoveries. First is the actual value of charge on a single electron, and secondly, that charge is always quantized. Okay, so we will always have charge as E, 2E, 3E, so on, Ne. Okay, we will never have charge equal to 2.5E or 2.6E. That is what he discovered. This is more or less quite true. Okay, for most of the things that you are going to study, this is going to be quite true. In fact, even through your further studies in college, you might find that this is quantization of charges a true phenomenon. Okay, but now we know there is existence of something that we call quarks, and those quarks have actually charge of E by 3, but ignoring those very quantum particles, we can say that charge is always quantized. So these are the two discoveries made by Millikan that we need to remember: the value of charge and the quantization of charge. Okay, now from this, once the value of charge was calculated as 1.6 multiplied with 10 to the power minus 19 coulomb, he very easily calculated mass of an electron. Since J.J. Thomson had already calculated the value of E by N, okay, that is specific charge ratio, by simply substituting the value of E that he calculated, Millikan was also able to calculate the exact mass of an electron. Okay, he was also able to calculate exact mass of an electron. The previous calculation of mass of electron were approximation. Okay, the calculations made by Thomson were approximations. He actually approximated that mass of an electron was 1 by 1000th of mass of an hydrogen atom. Okay, so that was approximately true. It is actually, we'll see the exact value later on. It is actually more nearer to 1 by 2000th mass of an hydrogen atom. We'll see the exact value. It is actually 1 by 1840 of the mass of an hydrogen atom approximately. Okay, so this is all we need to study over here, and in the next session we'll start with the discovery of proton. Okay, and we'll go into the details of those, and we'll also, obviously, for discovery of proton we'll also need to study positive rays or canal rays. Okay, so canal rays or channel rays or positive rays, and then discovery of proton, and then discovery of neutron. This is going to be our order for next few sessions. Okay, so until next time, and once again, thanks for watching Edupedia World videos.